everyone, I'm Jivika Kancherla and I'll be explaining you guys the solving of 10th question in homework 8 of the course Probability and Stochastic Processes. Before we look at the solving, let's have a quick look at the question. Show that if the normal process is wide sense stationary, then it is strict sense stationary. Let's have a look at the solving. So we're asked to prove that if a normal process is wide sense stationary, then it is also strict sense stationary. So the difference between wide sense stationary and strict sense stationary process is that for wide sense stationary, the expectation of a process is a constant number and the autocorrelation R of T1, T2 should be the autocorrelation of T1 minus T2. So that is the difference. And for a strict sense stationary process, that is the SSS, it is statistics will not be affected by any shift on the axis time. That is f of x for all x1, x2 all the way till xn and t1, t2 all the way till tn will be equal to f of x for all x1, x2, xt equal to xn and t1 plus epsilon, t2 plus epsilon all the way till tn plus epsilon. So in this question, we are asked to prove that fx of x1, x2, x3 for all the values of xn and also t1, t2 and t3 and all the values of tn is equal to fx of x1, x2 and so on till xn and t1 plus epsilon plus t2 plus epsilon plus t3 plus epsilon and so on till tn plus epsilon for any value of t1, t2, t3 and so on tn and any value of epsilon. It is given that x of t is normal, that is fx of x1, x2, x3 and so on xn, t1, t2 and so on tn is equal to 1 by root 2 pi power n into det c into e power minus 1 by 2 x minus neta power t c power minus 1 into x minus neta, where the value of c will be equal to the expected value of x minus neta into x minus neta transpose. Therefore, this is equal to expected value of xt1 minus expected value of x of t1 and so on till xtn minus expected value of xtn. Here we'll be calculating the det into x of t1 minus expected value of x of t1 and so on x of tn minus expected value of tn. If we simplify this equation, we will be getting it as r of t1 t2 minus neta square and so on till r of t1 comma tn minus neta square. In the same way, r of t1 tn minus neta square and also so on till r of t neta minus t neta tn minus tn minus neta whole square. This can be written as r of 0 minus neta square and so on till r of t1 minus tn minus neta square and r of t1 minus tn minus neta square and so on till r of tn minus neta square. This whole thing will be equal to c of t1 minus t2, t1 minus t3, which is so on equal to tn minus 1 minus tn. That is, this value is equal to c, can be written as c of ti minus tj for the value of I is not equal to j and the value of I and j will always be positive till n. Therefore, f of x1, x2 and so on till xn, t1, t2 so on till tn is equal to fx of x1, x2 and so on xn minus ti minus tj for I is not equal to j, I comma j is equal to 1 to n. That is, we are substituting this here. Now, this is equal to fx1, x2 and so on till xn, comma t1 plus epsilon minus tj minus epsilon for I is not equal to j, I comma j is equal to 1, 2 and so on till n. Therefore, f of x is equal to, that if you're solving this equation, is equal to x1, x2, x3 and so on till xn and ti minus tj for I is not equal to j, I comma j is equal to 1 to n. which is equal to f of x1, x2 and so on till n, t1, t2 and so on till n. This is the required equation that we wanted in this question. Therefore, we are able to strictly prove this. So like we were able to finally get this condition. Hence, we can say that if any function, normal function is wide sense stationary, then it is also strict sense stationary.